This is Mr. Precella continuing our discussion of linear programming, the graphical method, and today I want to illustrate a website that you can use that'll help you with some of these problems, especially these the application problems that are common. But it does a nice job of showing the graphs and so forth, and I'm just going to show that website to you now. So to begin, I'm going to use a little tablet here today. Let me open it, or let me unlock it. Okay, I'm using a tablet. I'll just open a web browser. I'm going to use this one right here. I don't know if you can see that. There's Chrome. I'm using just the web browser there. Okay, opens to Google. Okay, so let's see. Go to the website Phpsimplex. Oops, Phpsimplex.com/en. Go /en so it'll be in English. I have the, I don't know if y'all can see that. I have it written right here. Phpsimplex.com/en. The en gets it in English for you. And I'll say go. And let's see. Here it is. So to get started, it tells you, okay, it's an online tool. To get started, click this icon right here. Okay, just really a nice little website. So we stick here, click here. And at this point, the only type of the only method we've seen is the graphical method for solving linear programming problems, but there is something called a simplex method, and so you get to choose the method. But right now we're doing graphical, so let me just click here and change it to graphical. Okay. Let me see. Now, when you say graphical, that immediately assumes that there's only two decision variables, and that's right, x and y, only two decision variables. Now, how many constraints? When it tells you to enter the number of constraints, you don't count the non-negativity constraints. So how many less than or greater than statements do you have, not counting the non-negativity? Well, 1, 2. There are two constraints, so let's put that in. 2. Go. Oh, look at this now. It says, okay, you've got to choose. I've started setting it up. Instead of you writing x and y, they're just using subscripts here, x1 and x2. Well, okay. So they're using x1 and x2 instead of x and y. And so you first pull down menu to decide between maximize or minimize, and it's a maximize problem. Trying to see if I can arrange this in such a way that y'all can see both the problem. There it is. Okay. Maximize. Now, if it had been a minimize, you would just do the pull down menu and change it to minimize. So maximize 9 x1 plus 6 x2, given the constraints, 4 x1 plus 6 x2 x2, notice we have x1, x2 instead of x and y, less than or equal. Now if it had been greater than or equal or something, you see, look, there's the, you pull down to change them, but we have less than or equal to, oops, 24. Now let's come over here and do 9x1 plus y. Well, we assume that coefficient is a 1, right? Is less than or equal to, and this is another 24. Let's say continue here. And they write the problem out so you can check and make sure you punched it in right. 9x1 plus 6x2. Oh no, it says minimize. Well, let me see. I better go back. Why didn't someone tell me? Oh, it does say minimize. Let me go ahead and change that. Maximize. There, okay. Now let's do it. Let me see. Right, get it right. Oh, look, they misspelled maximize. Well, okay. Maximize 9x1 plus 6x2. Oops. 4x1 plus 6x2 less than or equal to 24. And you'll notice they always assume that non-negativity there. Look, they're already drawing the graph. So there's the shade, the feasible region there. Oh wow, this is really nice. I don't know if you can tell, but this region here is darkened. It's a shaded green. And it goes through, okay. So if you look at the corner points, 0, 0 is 1, over 0 up 4, and then A, the origin, C, and E. So point C, 2.4, 2.4, and E, you know what? Maybe we want to show the results as fractions. So you can click right there. Oh wow, look at that. Okay, E is the answer there. Okay, that's where the maximum occurs. The A, O, E, C, those are the corner points. A, the origin, C and E. Here's where they're punching in. And it says, I don't know if y'all can tell, that this is green. In green, the points for the solution, or in green is where the points for the solution is shown. In red, those are points that do not belong in the feasible region. You see, B and D weren't in the feasible region. There's B, and there is D. And this is really a nice way for to solve these problems, and that's going to be especially important for the word problems. For the word problems, I hope that you're doing something like this. Oh, I may as well write in the answer here. The maximum value is 36. And then it says, okay, where does that maximum value occur? Well, that would be at the ordered pair, the x and y, 12/5, comma 12/5. So right here, we type 12/5, comma 12/5. So I just wanted to show this website because for the word problems, I'm going to have videos where I'm just setting them up, and then once you get to get the answer, I'm hoping that you'll try using a website. There's a lot of different websites if you search online for things like this, but this is the one I found that I like the best. Okay, the Phpsimplex.com, then stick on /en just so that you'll know. So it'll be in English. Okay, so thank you for listening, and I hope this shows okay on the video. It looks okay up on the projector, so thank you.